Hi, in this video I'm going to talk about question number 7 of homework 7 of probability and stochastic processes course. So let's go straight to question number 7. In question number 7 we have z of t and we want to calculate, um, we want to find the expected value of z of t in part A. So for calculating expected value of z of t, I will substitute the formula for z of t, and because we know that n1 and n2 and theta are independent of each other, so we can um, split this to expected value of n1 times expected value of cosine plus expected value of n2 times expected value of sine. So uh, now in this part we should calculate the expected value of cosine and sine. So for calculating the expected value of cosine, we will write the integral. And we know that theta has a uniform distribution, so we can write it like 1 divided by 2 times pi, which comes out of the integral. And in the integral, we have the cosine times d of theta, and we know that the integral of cosine is sine. And if we substitute the ranges into our formula, we will come to 0. And we should now calculate the expected value of sine, and we know that the integral of sine is minus cosine, and again by substituting 2 pi and 0 we will get to 0. So the expected value for z of t is 0. Now let's go to part B. In part B we should find the r of t1 and t2, and we want to know whether z of t is WSS or not. So for calculating uh, r of t1 and t2, we should calculate the expected value of z of t1 times z of t2. And we have the formula of z of t, so we can substitute the value. And then we should multiply the two parts. And after multiplying the two parts, we will get to four expected values. So we should calculate these 4 parts. So let's go to each of these parts one by one. In the first part, we should calculate the expected value of n1, t1 times cosine, and n1 of t2 times cosine. So because we know that n1 is independent of theta, we can bring it down. And because we know that n1 and n2 are, let's get back to the question, are WSS, we can write them as r of n1 of tau. Okay, so we have the value of expectation of n1 times n1. Now we should calculate the expected value for cosine times cosine. And we know that cosine of A times cosine of B is equal to 1 divided by 2 cosine of A minus B plus cosine of A plus B. So we will substitute these values, and for one of them, thetas are removed. So we have some kind of constant which comes out of the expectation, and then we should calculate the expected value of cosine of WCT1 plus WCT2 plus 2 theta. So again, like the previous part, we should write the integral, and as we get the integral, we come to 0. So for the first part, we have 1 divided by 2 r of n1 of tau, and we know that we have a cosine of WCT1 minus WCT2, which we can write as WC cosine of WC tau. Okay, for the second part, we have expected value of n1 times expected value of n2, and n1 and n2 are independent, so we can write them, we can split them easily, and then we should calculate the expected value of cosine times sine. So we have a formula for that, which cosine of a times sine of b is equal to cosine of sine of r plus b minus sine of r minus b. So again, one of these do not have any random variable, and it's constant, and it comes out of the expected value. So we should calculate the expected value of sine of WCT1 plus WCT2 plus 2 theta. And after doing the integral, we will come to 0. And so for the second part, we have minus 1 divided by 2 sine of WCT1 minus WCT2, and we have the expected value for n1 of T1 and n2 of T2. As we know, n1 and n2 are WSS, so their expected values are in our constant values, and do not have T1 or T2 in their formula. So I just assigned mu1 and mu2 to these two respectively, as you can see. Okay, let's go to the third part. In the third part of this formula, again, we have expected value of n2 and expected value of n1, and expected value of sine times cosine. And sine times cosine of a times cosine of b can be written as sine of a plus b minus sine of a minus b. And after doing the calculations, again, we know that the integral is 0 for the first part, and the second part is the constant that comes out of the expected value. So we will have 1 divided by 2, mu2 times mu1 times sine of WCT1 minus WCT2 minus WCT1. And for the fourth part, we have again n2 times n2, that we know that this can be written as r of n2 of tau. And for sine of a times sine of b, we have cosine of r minus b and minus cosine of r plus b. And we know that one of them does not have any theta, and one of them which has theta. The integral of the one that has theta is 0, and we have a constant, so it comes out of the integral. So we will have 1 divided by 2 r of n2 times cosine of wc tau. And if we put all of these together, we can see that the sine of WCT1 minus WCT2 is going to be removed by another statement, another term, which is equal to this. And we will get to the final result of 1 divided by 2 times r of n1 plus r of n2 cosine WC tau. So we can obviously see that z of t is WSS because it is written as a function of t1 minus t2, which is tau. And for part C, we are asked if r of z is WSS, please calculate r of z of 0. So because now we have the formula of rz tau, we can put 0 for tau, and we can write it like this. And we know that the r of n1, 0, is equal to expected value of n1 to the power of 2. And we can write this for r of n2 exactly the same. So we have 2 expected values, one for n1 to the power of 2 and the other one for n2 to the power of 2. And so we get to our result. Thanks for listening to me. Bye.